Hello everyone. Now we are at the 4.2 experiment problem part 2. Continue from the previous video. That was the experiment problem part 1. So here I have a few questions on optimization problems. For the first question, given that the V equals to 10R minus 5 over 6 R cubed, find the positive value of R that makes the V a maximum. If I have this question, I want to find the value of R which makes my V maximum. I need to get my dV dr first. Okay, that will be 10 and 5 over 6, 3R squared. Simplify, you will have 5 over 2R squared. And to find the positive value R that makes the V maximum, I just as if that this is a curve and we want to get a maximum point, we will find the dV dr and then we let the dV dr equals to 0. Then we solve for the value of dr. Alright, then after that, later on, I'm going to check the value that we have. Is it making our V to be maximum or minimum? I have my R equals to positive negative 2. Now the question says that they just want a positive value of R, so I will just pick the R equals to 2, and we are not sure that this R equals to 2 will make our V maximum. We have to check with the second derivative test or first derivative test. So for this case, I will check with my second derivative test. I find my d2V dr2. I got 10, this is a differentiate 10, you got 0. And the negative 5 over 2, just copy down. And I have R, okay, this is a 2R. Then simplify it, you get negative 5R. Now I will substitute the value of R that we got just now, which is equals to 2. Substitute in, you will have a negative 5 multiplied by 2, you got negative 10, which is less than 0. So if your second derivative, when R equals to 2, is greater, you've got a value which is less than 0, you can make conclusion that the value of R, okay, V is, you can say that V is maximum when R equals to 2. For the question 2, you need to find the minimum value for the A, which A is equals to x squared plus y squared if x plus y equals to 10. You know, if we want to get the minimum value of A, we need to find dA, dx, or dA, dy. Since the A is consists of two variables, that is your x and y, I need to either dump one of the variable, which I can substitute x. I use this information, x plus y equals to 10. I will find x in terms of y, then substitute the x as 10 minus y into the A, so that I can make my A to be an expression which consists of only a single variable. So now here you can see that I want to substitute the x as 10 minus y. Then from here you can see I actually have a in terms of y only. If I want to get the dA dy, then it is possible for me to do that. So differentiate A with respect to y, you have a 2, 10 minus y power of 1, and then differentiate the inner function, you get negative 1, plus differentiate y squared, you get 2y. Simplify, you have a negative 2, 10 minus y plus 2y. Further simplify, you expand first, you get negative 20 plus 2y plus 2y. Then finally, you have a 4y minus 20. This is the dA dy. In order to find the value which will make our A to be, to find a value, minimum value of A, I will let the dA dy equals to 0, meaning that 4y minus 20 equals to 0. From here, we can get a y equals to 5. So when the y equals to 5, my x will be equals to 10 minus y, which is also equals to 5. 10 minus y, and the y substituted as a 5. I will get my x equals to 5. And are we sure that we cannot show that is this x equals to 5, y equals to 5 will make our a to be minimum or maximum? We need to test with the d2a, dy2. Meaning that I'm going to get the second derivative for this a function. So d2a dy2, I got 4. 4 is always greater than 0. Then we say that a is minimum when x equals to 5 and y equals to 5. But this is not our answer because the question is not interested on the value of x and y only, but they interested our final answer to be the minimum value of a. So now to get the minimum value of a minimum equals to, because the expression a is equals to x squared plus y squared, we need to put in the value of x and y into the function. So I have 5 squared plus 5 squared. That will be x squared plus y squared. 25 plus 25. That will be equals to 50. So this is our minimum value of a that is equals to 50. Question 3. Two quantities u and v in such a way that v minus u squared equals to 9. Another quantity p is defined as v over u. Find the positive value of u, which makes the p is a minimum. So to get a p minimum, I need to differentiate p either with respect to v or with respect to u. But since the question asks us to get a positive value of u, which make the p minimum, meaning that I need to dump the variable v. So just write down the function p is equals to v over u, and I have another information, v minus u squared equals to 9. You need to remember that the final answer we need to retain the u. So here I will find the v in terms of u. Later on, substitute this 9 plus u squared into the p function so that the u will retain and actually return the variable v. So now, substitute the v as the 9 plus u squared. Finally, I have a p in terms of u. So to get a p minimum, I need to differentiate p with respect to u. Before I differentiate, I think it's easier for me to, if I separate this function into two separate terms. I got my 9u power of negative 1 plus a u squared over u, I got u. So find your dp du. You have a negative 9u power of negative 2 plus 1. Or you may write this in the form of negative 9 over u squared plus 1. And after that, I will let my dp du equals to 0, meaning that negative 9 over u squared plus 1 equals to 0. Solve from here, we solve for the u. I have negative 1. And then I got my u squared equals to 9. The u equals to positive negative 3. The question says that they want the positive value of u. So I will choose the value positive, which the u equals to 3. In the bracket, you just you note that you are choosing the u, which is in the positive side. That is u equals to 3. And one thing you must remember that you cannot just leave your answer like that, because you need to prove that the u equals to 3 will make your p to be minimum. So for this question, for this case, I can use my second derivative test, meaning that I find the d2p du2. d2p du2 equals to 18 u power of negative 3. That is 18 over u cubed. Then I will substitute this u that I got just now, u equals to 3, into my second derivative. Then I got a positive value. Alright, I got a positive value. When your second derivative is having the positive sign, meaning that you can make the conclusion P is minimum when U equals to 3. Alright, so we need to read back the question. Find the positive value of U which make the P a minimum. Yes, they just want the value of U and they are not interested on the minimum value of the P. So we can just leave our answer in this form. Question number 4. Find the minimum value of L equals to x plus y if x and y related by the equation xy equals to 25 if x greater 0, y greater than 0. So for this question, we want to find the minimum value of L, meaning that we need to find dl, dx, or dl, dy, and then we let our first derivative equals to 0. But now we need to decide we are going to dump the x variable or y variable, meaning that we are going to leave the x or y. We need to make our decision. And if we want to dump x, all right, we need to find x in terms of y first. We got x equals to 25 over y from this equation. Then we substitute 25 over y as x into the L. 25 over y as our x into the L. We got 25 over y plus L. Then we're going to find the dl dy. Before this, I will change the 25 over y into 25 multiplied by y power of -1. Then find the dl dy. We got a -25 y power of -2 plus 1. Then if you want to simplify, go ahead. -25 over y squared plus 1. This is the dl dy. And we wish to find the value of minimum value of L, meaning that we need to let our dl dy equate it to 0. Sorry. This is plus 1 equals to 0. And now we're going to find the y value. Solve this. You got 25, y squared equals 25, and y equals to plus minus 5. Then we read back the question. We want the y which is greater than 0. So we just pick our answer. Y equals to 5 because the question states that y must be greater than 0. Then we are actually we need to find the L maximum. The minimum value of y, and we're not sure this y equals to 5, whether it can make our L to be maximum or minimum. We need to test with the second derivative. That means we need to find the d2L dy2. From the d2L dy2, that will be 50 y power of -3. Okay. We bring down the -2 to the front, multiply by -1. We got our 50. All right, 2 multiplied by 25, 50, and then the power -1, you got -3. Then simplify, you have a 50 over y cubed. Substitute y equals to 5 into here. d2L dy2, when your y equals to 5, will be equals to 50 over 5 power of 3, and we get 2 over 5, which is greater than 0. If your second derivative is greater than 0, we can make conclusion that L is minimum. L is minimum when y equals to 5. And we are not interested on the value of y, but we are actually, the question wants the L minimum, the minimum value of L. So we need to find, we substitute the y equals to 5 into the L expression, the expression of L, which is 25y plus y. So substitute the 5 into this expression. We got 25 over 5 plus 5. So finally, we have a 10. So this is our minimum value of L. Let's read up the question 5. Variable x and y are related by the equation x plus y equals to 10. So this is the equation which is showing the relation between the x and y. And a third variable p is defined as x squared multiplied by y. Find the values of x and y such that the p is maximum. We need to find the value of x and y will make our p, which make our p maximum. So to solve this question, we need to get a dp dx or dp dy. So we need to decide, we need to dump one of the variable, either x or y. So how do we dump it? We are going to take this equation and find out. Either will write your x in terms of y or y in terms of x. If I write y in terms of x, and then I substitute y as a 10 minus x into my p expression, meaning that I'm going to leave the variable x. So later on, we need to find dp dx. All right. So this is our expression for the p. Substitute the y inside. You will have p equals to x squared multiplied by 10 minus x. So can you see that my expression of p now only consists of the variable of x? Now we need to find dp dx. Before this, I expand first. Then find your dp dx. You got a 20x minus 3x squared. Then to find the x which make our p to be maximum or minimum, we need to let our dp dx equals to 0. So let our dp dx equals to 0. To solve this, I'm going to factor out the x. Factor out the x, you got 20 minus 3x. So one of the answer has to be x equals to 0. The other one is 20 minus 3x equals to 0. Then we have 3x equals to 20. Finally, we got x equals to 20 over 3. Now we find the d2p dx2. See which answer will make our p to be maximum. So d2p dx2 will be 20 minus 6x. When the x equals to 0, you can just calculate without writing it out. You substitute x equals to 0 inside. This will be 0. 20 minus 0, of course, positive. So when the d2p dx2 is positive, meaning that the p will be minimum. So I would just substitute this x equals to 20 over 3 into my d2p dx2. I got my answer, negative 20. 20 minus 40, you got negative 20. When your d2p dx2 is less than 0, your conclusion is p is maximum when x equals to 20 over 3. Then now you need to get a corresponding value of y. So y equals to 10 minus x. Y equals to 10 minus x means that the value of y will be 10 minus 20 over 3, which is 30, 10 over 3. Okay, 10 multiplied by 3, 30, 30 minus 20, yes, 10 over 3. So we say that p is maximum when x equals to 20 over 3 and y equals to 10 over 3. You must prove this value will give a p to be maximum by the second derivative test or first derivative test. All right, look at the question 6. Find the length and width of the rectangles that has the given perimeter and maximum area. So I want to get a maximum area. Given the information is a perimeter for the question 6a, perimeter is 100 meter. So firstly, I will draw a rectangle first, so that I can generate idea from the diagram. I will just put this as a L and the width as a W, the length as L and the width as a W. Now I want to get the maximum area. Maximum area, then firstly you need to have an expression on area. That is L multiplied by W. Length multiplied by width, that will be the area. And now to get the maximum A, I need to find the ADL or the ADW, right? So either what we want to leave L in our expression or W in our expression. We are going to dump one of it. So how do we dump one of the variable? I'm going to deal with this information. Perimeter is equals to 100 meter, meaning that I want to form an equation according to this information. All right. Then from what it means by perimeter, perimeter meaning that we are going to add up all the length of the edge of the rectangle. So I got 2L plus 2W equals to 100. From this equation, we simplify, we'll have L plus L plus W equals to 50. And from here, I will say that the L equals to 50 minus W. Meaning that if I write the L in terms of W, when I substitute in, you won't see L anymore. You only will leave the variable W in your expression. So here I find my A by substituting my L into here. L is 50 minus W, so I have 50 minus W multiplied by W. Expand it, you will have 50W minus W squared. Then to get the maximum A, we need to find the ADW. We got the 50 minus 2W, and we will let our ADW equate to 0. Then we have W equals to 25. Okay, so we're not sure that this W either will make our A to be maximum or minimum. We're going to test with the second derivative test. d2a dw, to find your second derivative by just differentiate your dA dw with respect to W one more time, you get negative 2. So since negative 2 always less than 0, what can we do? We can make conclusion that the A is maximum when W equals to 25. Alright, then we will refer back to the question. Question asks us to find, we need to answer the question exactly what they ask. Length and width, we need to find the L and W when which will give a maximum area. So this is W, we need to one more value so that we can get a full answer. That is the L, sorry. You need to get the L, and L equals to 50 minus W. L equals to 50 minus W. So L equals to 50 minus 25. That will be equals to 25. And you can see that L and W having the same value, meaning that A is maximum when your rectangle is actually form a square. Alright, a square, which is the length and the width is 25 meters. Okay, you may write your unit as a meter. Okay, that's it. And for the question 6b, alright, it's the same, similar to the question A, but just the perimeter, they change it into the P units. Meaning that later on, you're going to substitute, you can try out this question, and later on, the 100 over here, you're going to substitute as a P. Alright, then you follow the same method, same approach, then you can get your answer. And the answer is P over 4. L is a P over 4 meter, and the W also P over 4 meter. Alright, so this is the answer, and you may try out using the same method as A. Question 7. Find the length and width of a rectangle that has the given area and a minimum perimeter. So for this question, later on, I will try out this question B. I will show the solution for the question B, and the question A, I'll leave it for you as exercise. First of all, you sketch a rectangle, and you note this length of the rectangle as L and the width as a W. So now we want to get a minimum perimeter, meaning that you need to have an expression on the perimeter. Perimeter meaning that you add up all the edges. The length of the edges, that will be 2L plus 2W. I'm going to find the minimum parameter, meaning that I need to find dp dw or dp dl, depending on which variable we will eliminate it. So how do we eliminate, or we say that we want to change this expression into a single variable? We'll look at this information. The area is equals to a square meter, meaning that area alright, then given the area is a square meter, so we need to form an equation which shows us the relation between the L and the W. So A equals to L multiplied by W, meaning that if later on we want to get a dp dw, we're going to dump the variable L. So here I find the L in terms of W. L equals to A over W. Substitute A over W inside your P. You will have a 2A over W plus 2W. And simplify our expression in this form. Later on, we're going to find dp dw. Differentiate this, you will get negative 2a, w power of negative 2 plus 2. Differentiate 2w with respect to w, you get 2. Okay, you can rearrange your answer of dp dw to be like this. And in order to get a p minimum, yes, minimum p, we need to let the dp dw equals to 0. So negative 2a over w squared plus 2 equals to 0. Then you have your negative 2a over w squared equals to negative 2. So very obviously that a negative 2 can be cancelled off. Then finally, you will have a equals to w squared. Okay, or w equals to positive negative square root of a. Okay, so since the w representing the width of the rectangle, so we will dump the negative value. We only will accept the positive square root of a because w always greater than 0. Okay, then we're not sure. Again, we need to confirm is this value will make our p to be minimum. We need to test with the second derivative. Check with your second derivative. Get your d2p dw2. You will have a positive 4a w power of negative 3 plus 0. Simplify, you will have a 4a over w cubed. Then substitute the value that you got it just now into the second derivative, meaning that you substitute w equals to square root of a inside. You will have 4a over square root of a power of 3. And very obviously that this will produce a value which is greater than 0. So when the d2p dw2 is greater than 0 or positive, then your conclusion is p is minimum when w equals to positive square root of a. And the question, again, we look back at the question, read back the question. We want to find the length and the width, meaning that we need to get the value of L and the W. So just now we already got the value of W. Now we get the value of L. L given as the A over W. Okay, so substitute W inside. You will have A over square root of W, square root of A. Because the W substituted as a square root of a, then you have 1 over 2. Okay, power of 1 over 2, or we can say that the L equals to square root of a. Alright, so this is your answer for the L, the length, and the W as your width. That both are square root of a. For the question A just now, the A is area given as a 64 square feet, meaning that later on, we will use my solution as D and substitute your A as a 64. Then continue with the solution exactly like what I showed just now. Okay, you will get the answer. And the answer is, you will get the L is 8 feet and the width also 8 feet. This is the answer for the question A. Let's try it out. For the question 8, if S is given as a function in terms of R, and find the minimum value of S and the value of R. So for this question, your answer, suppose you have two answers. One is a minimum value of S, the other one is the value of R, which make the minimum value. Alright, so this question, they want two answers. One is minimum value of S and the other one is R value. Alright, so this is a very simple question. Write down the function in terms of R. Get your DSDR first because your function already in a single variable, so you just differentiate it without changing anything. Then you let your DSDR equals to 0. You get a 10 over 8, 5 over 4. Alright, R equals to 5 over 4. And we have to confirm that is this R make our S to be minimum. We need to find D2S, dr2, which will get positive 8, and the value of a second derivative is positive, meaning that we can make conclusion that S is minimum when the R equals to 5 over 4. Okay, after that, we need to find a minimum value of S, which I will find as minimum. Substitute into the X expression, which is your 4R squared minus 10R plus 7. 4R squared minus 10R plus 7. Is it plus 7? Yes. Okay. Then we can calculate with the assist of calculator, we can calculate the value. 3 over 4. This is the S minimum. Question 9. If A is equals to xy and 2x plus 5y equals to 100, find the maximum value of A. We need the one answer, maximum value of A, and the other answer is values of x, and the other one answer is the value of y. So we need to show three answers. Alright, so we in our solution, we must show and stress on these three answers. Firstly, we have A equals to xy. If you would like to find the maximum value of A, you need to eliminate one of the variable, make it single variable. To make it single variable, I'm going to use this equation. 2x plus 5y equals to 100, meaning that I can write 2x equals to 100 minus 5y and 100 minus 5y over 2. This is your x. I'm going to substitute this into my A, into my expression of A. A equals to 100 minus 5y over 2, and this is going to multiply by 1. Alright, to make your differentiation, the A dy to be easier, we can just multiply inside this 100, expand it. 100 divided by 2, you get 50. 50 multiplied by y, 50y. And here, the second term, you have a 5 over 2, negative 5 over 2y squared. Alright, so together, maximum value of A, I'm going to find the A dy. The A dy equals to 50 minus, bring down the 2 inside here, I multiply by negative 5 over 2, you get negative 5. And the power of 2 minus 1, you get negative 5y. Okay, then we will let the A dy equals to 0, meaning that 50 minus 5y equals to 0, 5y equals to 50, and y equals to 10. Okay, yes. Then after that, you need to make sure that is this y value, which is equivalent to 10, will make our A to be maximum. We don't know, we're not sure. We need to verify it by using the d2a dy2. So d2a dy2, from here we differentiate one more time with respect to y, we get negative 5. If your second derivative is less than 0, what is the conclusion? You can say that A is maximum. A is maximum when your y value equals to 10. Alright, so again, we read back the question to ensure that is our answer complete. We need to get the maximum value of A, we not yet get it. Value of Y, yes, we already got it, but value of X, not yet. Okay, so to get the corresponding value of X, we just substitute into here, into this expression. Alright, so X equals to 100 minus 5 multiplied by 10, that is a Y over 2. Okay, so you have 100 minus 50, that will be 50. 50 divided by 2, 25. Your corresponding value of X will be 25. First one is Y, second one is the X. And then you need to get the A maximum. To get the A maximum, I'm gonna to consider this expression, A equals to XY. A equals to XY. Alright, so take your value of X, okay, what you that you got it just now, 25, multiplied by the Y, which is 10. Okay, and this is 250. This is the answer for the A maximum or maximum value of A. Question 10. Determine the turning point of this cubic function and state the nature of this point. First of all, to get the turning point, meaning that we want to get the stationary point. Stationary point, it has either can be maximum or minimum. We need to determine whether the point that we got is a maximum point or relative minimum point. That means by nature of this point. To get a stationary point, we find the dy dx first. We got a 6x squared minus 30x plus 36. That will be our dy dx. And let the y at dx equals to 0. To solve this, we need to, all this term can be divided by 6. We're going to simplify it first. And now we factorize and then we solve. Alright, then we have two values of x. One is 3, the other one is x equals to 2. Then because of this question state points, meaning that we need to get the corresponding value of r, which when x equals to 3, the y equals to, substitute in. When x equals to 3, you got y equals to 23. And when x equals to 2, substitute into the y function. We got to answer the question. Turning points, we have 3, 23. And the other one is 2, 24. Later on, we need to check whether these 2 points, the nature of these 2 points, either to be maximum point, relative maximum point, or relative minimum point. So for this question, I might use the first derivative test. For the first derivative test, you can sketch your table first. The table is supposed to be 3 rows and 4 columns. For the first point, I check for the first point for x equals 3, y equals to 23. The first row, this is for those x value, and the second row is for sine of dy dx. And the third row will be the pattern of the y. So for the first row, in the middle, I will have x equals to 3. At the left hand side, you will have a value less than 3, which is very close to 3. And for the right hand side, is a value close to 3, but it's greater than 3. Then you substitute the one value, which is less than 3, into our dy dx. Here we write down the dy dx as a 6x squared minus 30 plus 36. Substitute a value which is less than 3. For example, you can substitute 2. 2 substitute inside, you will have 2, 4, 6, 4, 24 minus 30 multiplied by 2 plus 36. When I substitute 2 inside dy dx, I got 0. Oh, sorry. Yeah, 2 is supposed to be another one turning point. So I cannot substitute 2. Substitute 2.5. 2.5 into this, into the dy dx. Let's see what happens. You have a negative value. When you substitute 2.5, you can take write it down here. Substitute 2.5, you will get a negative 1.5. So you just write down the sign. And of course, when you substitute 3, you will get 0. Substitute a value which is greater than 3. You can use 4 and see what happens. Substitute 4 into this dy dx. All right, you get 12. You get 12. So the sign is positive. The pattern for the dy dx negative, meaning that your y is decreasing. And if 0 means it's a horizontal line. If a sign of dy dx is positive, means that the y is increasing. Based on these 3 lines, you can say that the point at the x equals to 3 is a minimum point. So make your conclusion. Just write down your conclusion. 323 is a relative minimum. Point. And you can use the same approach to check for the point 224. For point 224, dy dx is given here. And here is the x. This is a sign of dy dx. And the last one for pattern of y. In the middle, we have x equals to 2. Here, you substitute x less than 2 and substitute x greater than 2, which is very close to 2. We're not going to substitute 3 because 3 is one of the stationary points. Then substitute the x equals to 2 into your dy dx. Confirm, you will get 0. Substitute 1 inside, you will have 6 minus 30. That will be negative 24. Negative 24 plus 36, you got a positive sign. Substitute 2.5. Here, you get negative sign. Just now, we already did this. Substitute 2.5, you get negative sign for dy dx. So from the pattern of the dy dx, from the sign of the dy dx, you can trace the pattern of the y, which is positive, means that the y is increasing. 0 means horizontal line, and negative means dy dx is your graph is decreasing. So from this 3 line, you can trace your graph, your curve. Very obviously, you will see that when x equals to 2, this will be the relative maximum. You can make your conclusion where 224 is a relative maximum. For this question, I use the first derivative test. Of course, you can use second derivative test to test the maxima, to test the nature of the points. No problem. But here, I show by using the first derivative. You have answered those questions. State the nature of this point, you have done it. Find turning point, you have done this. Question 11 is a simple question where the x and y is equal to 8. This is information given just to show us the relation between the x and y. And we want to find the maximum value of p, which is equals to xy. So we need to convert the p into a single variable by using this relation, where I will find my x in terms of y. I got 8 minus 1. Substitute the x as 8 minus y, then all your p will be in single variable. That is only the y in terms of y. Then get your dp dy. You have your 8 minus 2y. To get the maximum value of p, you will make your equate your dp dy equals to 0 and solve for the y. You have a 4, y equals to 4. Then this question is not interested on the y and x value. They want us to find the p, maximum value of p. So I'm going to check, is this y can make my p to be maximum? I will check with the second derivative. I got negative 2. Negative 2 always is less than 0, or we say negative, meaning that p is maximum when y equals to 4. then I'm going to get the value of the P, which is the maximum value of the P. P max is equals to 8 minus Y multiplied by Y. Now I'm going to substitute the 4 inside. 8 minus 4 multiplied by 4. That will be 4 multiplied by 4, that will be 16. Meaning that the maximum value of P is equivalent to 16. And later on, this is the first video, part 1, for the optimization problem. For the next video, part 2, I will continue the question from the question 12. This is question 11, from question 12 to question 19. See you at the next video.